Greetings of the day. In this session, we will concentrate on how to plot a root locus with an example. This is the third example I am considering. So let us consider a problem. Sketch the root locus of the system having open loop transfer function g of s h of s equal to k divided by s into s plus 2 into s square plus 6s plus 25. So from the given problem statement, g of s h of s equal to k divided by s into s plus 2 into s square plus 6s plus 25. So initially we need to find number of branches. To find out the number of branches, we need number of open loop poles and open loop zeros. So number of open loop poles in this is n equal to 4. That is because the order of the denominator polynomial of g of s h of s is s to the power 4. So number of open loop poles is equal to 4 at s equal to 0, s equal to minus 2 and s equal to minus 3 plus or minus j4. These are the pole value we obtained by equating denominator polynomial to 0. Number of open loop zeros m equal to 0. This is because in the numerator s polynomial does not exist. So number of open loop zeros are 0. So number of branches is maximum of n or m. So in this maximum is 4. So number of branches equal to 4 and n minus m branches terminates at infinity. So here m is equal to 0. So all the 4 branches which are starting from these 4 poles 0, minus 2 and minus 3 plus or minus j4, which are start from these 4 poles terminates at zeros at infinity. So based on this, we will mark these poles and zeros in the s-plane. So this is the s-plane, imaginary axis, real axis. 4 poles s equal to 0, s equal to minus 2, s equal to minus 3 plus j4, s equal to minus 3 minus j4. So based on the rule number 3, part of real axis the part of the root locus. So any point if I consider between 0 to minus 2, any point if I consider to the right, there exists only one pole. So one pole which is an odd number, so entire this is the part of the root locus. And if I consider any point to the left of minus 2 up to minus infinity, any point if I to the right, 2 poles and zeros exist. Total 2 poles, zeros are not existing, but total 2 poles exist, which is an even number. So this is not a part of the root locus. Similarly, root locus start from open loop poles. So the direction of the branches, 2 branches, one start from minus 2. So the direction is away from the pole minus 2. And another branch start from the 0, which is away from 0, this pole. So this is the initial plotting of the root locus. Next we will consider angle of asymptotes. So the formula for angle of asymptote is 2q plus 1 into 180 degree divided by n difference m, where q is equal to 0, 1, 2, 3. Only up to 3 because n minus m minus 1. So 4 minus 0 minus 1 is a 3. So what are the angles? So if I substitute q is equal to 0, so 180 by 4, 45 degree. If I substitute q is equal to 1, 3 into 180 by 4, it is 135 degree, 225 and 315 degrees. These are the 4 angles of asymptotes. About the centroid. Centroid is obtained by sum of the open loop poles minus sum of the open loop zeros divided by n minus m. So sum of the open loop poles 0, -2, -3 plus J4, -3 minus J4. J4 minus J4 gets cancelled. So -8 divided by 4, that is -2. So we will add this centroid and angle of asymptote to the previous graph. So by adding at -2, I am plotting 45 degree, 135, 225 and 315 degree. So it is not looks like a 45 degree. All of you might be thinking how this is the 45 degree. But here the scaling are different. X-axis 1 unit means around 2.5 centimeter, whereas this is 1.5 centimeter. So here I have plotted based on this distance and this distance, X and Y distance, because in 45 degree this X distance and Y distance must be the same. So here this distance is 2, this is also 2. So this is the 45 degree. So similarly here, so all these angles are 45 degrees, but not actually in terms of degrees. Instead of that, it is better to plot based on X and Y axis. For 45 degree, tan 45 is equal to 1, that means X and Y are equal. So I am considering this and this are -2, 0, 0, 2. So 45 degree, 135, 225 and 315 degrees. Now we will find breakaway points. To obtain the breakaway points, first we need to find the characteristic equation, that is 1 plus g of s h of s equal to 0. For this particular problem, 1 plus k divided by s into s plus 2 into s square plus 6s plus 25 equal to 0 by rearranging s to the power 4 plus 8s cube plus 37s square plus 50s plus k equal to 0. So from this characteristic equation we need to separate k as a function of s. By doing so, we will get k is equal to minus of s to the power 4 plus 8s cube plus 37s square plus 50s. To find out the possible breakaway points, we need to differentiate k with respect to s and equate to 0. So dk by ds equal to minus of 4s cube plus 24s square plus 74s plus 50 equal to 0. So the roots of this equation are minus 0.5 and minus 2.55 plus or minus j 2.72. So here the roots possible breakaway points are real values as well as a complex. But whether this real value is a valid breakaway point or not, we can check from the graph. But about this complex value, need to check using angle condition. So to check the validity of minus 2.55 plus j 2.72, use angle condition. What is the angle condition says about angle of g of s h of s at s equal to s1 is if it is odd multiple of 180 degree, then it is a valid breakaway point. It is a point on the root locus. So first we will find out angle of g of s at s equal to s minus 2.55 plus j 2.72 is angle of k divided by s into s plus 2 s square plus 6s plus 25 at s equal to minus 2.55 plus j 2.72 is obtained by substituting s equal to this value in this expression, that is s plus 2 s square plus 6s plus 25. Then finding the angle. So by doing so, I will get an angle as 109.88 degrees. So angle of g of s h of s at s equal to minus 2.55 plus j 2.72 is 109.88 degree, which is not an odd multiple of 180 degree. So this is not a part of the root locus. That means this is not a valid breakaway point. So if this is not a valid breakaway point, by the property of the symmetry, minus 2.55 plus minus j 2.72 is also not the part of the root locus. So if 1 is not a part of the root locus, complex conjugate is also not a part of the root locus. So if I check the real part, that is minus 0.9, it is the part of the root locus. So this is a valid breakaway point. So out of the 3 possible breakaway points, h is equal to minus 0.9 is a valid breakaway point. Now we will concentrate on how to find intersection with imaginary axis. To find the intersection with imaginary axis, we need a characteristic equation, because intersection with imaginary axis is obtained from Routh-Arvez criteria. So characteristic equation for this particular problem is 1 plus k divided by s into s plus 2 into s square plus 6s plus 25 equal 0. Now we will concentrate on how to find angle of departure. Now angle of departure at pole minus 3 plus J4 is phi d equal to 180 minus phi, where phi is equal to sigma phi p minus sigma phi z. In this case, sigma phi z is 0 because no zeros exist in this system. Open loop zeros are 0. So sigma phi z is 0. That is, angle made by zeros with respect to this is 0. And sigma phi p is equal to phi p1 plus phi p2 plus phi p3. What are these phi p1? In this particular case, I have considered this as a phi p1. So this phi p1 angle is equal to 180 degree minus this angle. So this angle is tan inverse of 4 by 3. So this phi p1 is equal to 180 minus tan inverse of 4 by 3, that is 126.87. So phi p1, this angle is 126.87. Phi p2, in this particular case, this angle is considered as a phi p2, where this angle is equal to 180 degree minus this angle, where this angle is tan inverse of 4 by 1. So phi p2 is equal to 180 minus tan inverse of 4 by 1, that is 104.04 degree phi p2. Phi p3, it is a perpendicular because it is lies on same line of axis, so this angle is 90 degree. So total phi p, which is equal to phi p1 plus phi p2 plus phi p3, which is equal to sum of all these three, which is equal to 320.91. So in this case, as phi z is equal to 0, sigma phi p itself is a phi. So this is phi. So angle of departure at pole minus 3 plus j4 is 180 minus 320.91, which is equal to minus 140.91 degree. So from this pole, it will start branch at an angle of minus 141 degrees. So somewhere around this angle, minus 140. So what about the angle of departure for this particular pole? As the first rule says, the root locus is symmetrical about real axis. So it is, if it is minus 141, then angle of departure for this is negation of that is plus 140.91 degree. So by the property of symmetry, angle of departure at minus 3 minus j4 is 140.91 degrees. Now if we collect all the information, that is the number of branches, starting point and all, we will get a root locus like this, where these are the poles 0, minus 2, minus 3 plus j4, minus 3 minus j4, and angle of departure is breakaway point is minus 0.9. At this point, these two branches breaks away and moves in this direction, and it will intersect the imaginary axis at plus j2.5 and minus j2.5, and it follows the angle of asymptote with 45 degree and 315 degree. With respect to this complex poles, its branch starts at an angle of minus 141 degree and then follows the angle of asymptote 135 degree. Here this is plus 140 degree, it starts from plus 141 degree and it follows the angle of asymptote of 225 degree. So this is the complete root locus for the given system with open loop transfer function g of s h of s equal to k divided by s into s plus 2 into s square plus 6s plus 25. Thank you.